Hey everyone, welcome back. Today, we're diving into a groundbreaking study that's redefining how we secure healthcare in the age of smart technology. Imagine a future where your wearable heart monitor, hospital AI diagnostics, and telemedicine apps are all interconnected, delivering personalized care, predictive insights, and real-time health tracking. But here's the catch. This hyperconnected world also creates new vulnerabilities. And that's exactly where this research shines. So what's Healthcare 5? Think of it as the next evolution of medical technology, powered by AI, IoT devices, and real-time data. It's about hyper-personalized care, predictive diagnostics, and sensors that monitor your health 24/7. But here's the problem. The more connected these systems become, the more exposed they are to cyber threats. A single breach could compromise sensitive patient data, disrupt life-saving devices, or even endanger lives. Most cybersecurity systems today focus on analyzing network traffic, like a bouncer checking IDs at a club. But here's the gap. They've been ignoring a critical piece of the puzzle: biomedical data. It's like using only a building's security cameras to detect a break-in, but ignoring the motion sensors in the rooms. This study flips the script by combining network data and biomedical signals, like heart rate or temperature, to detect threats more effectively. The researchers used a tool called XAI, or Explainable AI, to make sense of this data. XAI isn't just about accuracy, it's about transparency. It's like asking an AI, why did you make that decision? In this case, they trained a model called XGBoost on a dataset called WSDL-EHMS 2020, which includes both network traffic and biomedical sensor data. The results? Remarkable. For detecting normal traffic or data tampering, the model achieved 99% accuracy. But the real breakthrough? When it came to spotting spoofing attacks, where hackers mimic real data, it still managed an impressive 81% accuracy. And here's where the science gets fascinating. Using a technique called SHAP values, they discovered that network data was the big hero here. But biomedical features? They played a crucial role in catching specific threats. For example, temperature readings had a SHAP value of 0.37, meaning they were a significant factor in identifying spoofing attacks. So why does this matter? Current cybersecurity models often ignore biomedical data, leaving a blind spot in protecting critical health systems. This study shows that by integrating both network and biomedical insights, we can build smarter, more transparent defenses. It's not just about catching threats, it's about understanding why they happen so we can stay one step ahead. In a world where our health data is more connected than ever, this research is a game changer. It's a call to action for developers, doctors, and cybersecurity experts to think beyond traditional methods and embrace the full spectrum of data, biomedical and network. Let's break it down. The study used a dataset called WSDL-EHMS 2020, which simulates real-world scenarios, medical devices sending patient data through a network. But here's the catch: this network isn't secure. Malicious actors could intercept or alter that data, putting patients at risk. The dataset includes 16,000+ samples of network traffic and biomedical data, like heart rate and oxygen levels. But instead of just labeling things as normal or attack, they used a more detailed system. 3 categories: benign traffic, spoofing attacks, where hackers mimic real data, and data alteration, where they change the data itself. This granularity was key for their analysis. Now, how did they figure out what's going on? They trained machine learning models to spot these threats. But here's the twist. They didn't just want the models to work, they wanted to understand why they made certain decisions. That's where SHAP analysis comes in. Think of SHAP as a detective tool that breaks down how each feature, like a device's port number or a patient's temperature, influences the model's predictions. The team tested 4 models: XGBoost, random forest, decision tree, and support vector machines. While all performed well for benign, traffic, and data alteration, spoofing attacks were a challenge. Spoofing is tricky because attackers mimic real data, making it hard to tell the difference. And here's the kicker: only 12.5% of the data was malicious, creating an imbalanced dataset. That's like trying to find a needle in a haystack. Here's what they found. Biomedical features like blood oxygen levels, SpO2, temperature, and heart rate variations showed up in the analysis, but their influence was like a quiet whisper. Their SHAP values didn't swing wildly, meaning they didn't drive the AI's decisions as much as other data. But network-related features, like packet sizes or timing anomalies, were the heavy hitters. For example, in data alteration attacks, the AI relied almost exclusively on network clues. Now let's talk about spoofing attacks, when hackers mimic real devices. The study found that network features like sport, a technical term for port numbers, and body temperature had the biggest impact. Lower sport values made the AI less likely to flag an attack, while higher values screamed danger, temperature. It had a wide range of influence, suggesting the AI notices even small body temperature shifts. But here's the twist. The exact connection between temperature and spoofing isn't fully understood yet. More research is needed. Interestingly, network features like DstJitter, which measures timing inconsistencies, and SRC load, source traffic volume, also stood out. Lower values here hinted at potential attacks, which makes sense. Spoofing often messes with timing and traffic patterns. But here's a catch. Spoofing detection was weaker compared to other attack types, like malware or denial-of-service attacks. Why? The study suggests spoofing's subtle nature might make it harder for AI to catch. So what does this mean for the future of healthcare security? The research highlights a big gap. While network data dominates current AI models, biomedical data, like heart rate or glucose levels, still has untapped potential. But right now, it's like a quiet voice in a crowded room. The team's next steps: exploring more complex datasets, especially those that mix real-world clinical scenarios with cyber threats, and diving deeper into how AI interprets both network and biomedical clues. This isn't just about code, it's about protecting lives. As IoT devices become more common in healthcare, understanding what AI sees could mean the difference between a timely alert and a missed threat. Stay curious, because the next breakthrough in explainable AI might just be a few SHAP values away. Thanks for watching. If you want to explore how AI deciphers health data, or what the future of secure IoT looks like, hit subscribe. Let's keep unraveling the mysteries of technology together.